Big day today, trigonometry fans. Bringing back Mr. Parker for the big day here. Remember this is Mr. Parker circa 1988, I think it was, with the mullet and the hat. And he probably did not have the beard going, but yeah, he's a proud member of Forest Lake, graduating class of Forest Lake High School. So anyways, had some kids request I bring Parker's image back. So in honor of him, in our last lesson of matrices, I'm doing it. Big idea today. We're going to solve these matrix systems using inverses. So classic example from Algebra 2 and Algebra 1 is you have a systems of equations. And what we're going to do is we're going to use matrices to ultimately help us solve that. And we're going to use some of the tools that we've talked about in the last couple lessons to solve this system. So the first thing we want to talk about is just the setup to these. Is if we have a matrix A times X that equals B, we can use a matrix equation where A, the first matrix, is called the coefficient matrix. X, that's called our variable matrix. That's going to be our things that we're going to solve for. And B is the constant matrix. So this manifests itself in ways like this. So here's a classic system. We're solving for X and Y. We're looking for two numbers that when you add them it equals 8. And that when you multiply the first one by 2 and add it to the second one, it equals 1. Now our classic method, we could use guess and check. We could solve for one variable and substitute in the other one, so on and so forth. A fast way to do this is to use matrices. And here's what we do. We take our first matrix, we call that the coefficient matrix. That's set up from this coefficients of X and Y, 1 and 1. Second row is 2 and 1. It goes here. Second equation is called a variable matrix. It just represents the two variables that we're talking about. And notice instead of just one row with two columns, it's two rows with one column, so X and Y. And that's equal to our coefficient matrix. I'm sorry, our constant matrix. Our constant matrix is what the sum of these two variables is always equal to. It's equal to 8, and this one's equal to 1, so on and so forth. Okay, so what we do when we're going to solve this equation, to solve this equation here, what I want you guys to think about doing is in algebra, we talk about what do? We divide. Well, we can't divide by A, so instead, this is what we're going to do. We're going to take matrix A, and we are going to multiply both sides by the inverse of A. And what that does, make sure we do it in this order. This order on this side is ultra important. So matrix A times the matrix inverse of A, that basically cancels this out. This is equal to the identity matrix, which is just equal to now our variables. So this is what we need to solve for. We need to solve for the inverse of A times B. And we talked about how you find the inverse of matrices. What do? We take 1 over the determinant. So let's start and find the determinant. Remember, the determinant of A is the cross product of 1 and 1 minus 2 and 1. So that's 1 minus 2, so it's minus 1. That's the determinant. So the actual inverse of matrix A is 1 over minus 1 times, and we got to take matrix A and put it in a different form. We got to switch this, and now because these are 1 on 1, it doesn't really look like I switched them. And then we make these negative, and then we multiply that by matrix B. Okay, so let's do one thing at a time. So this simplified is minus 1. So what I'm going to do is I'm going to multiply each of these by minus 1. I'm not going to multiply the second matrix, just this by minus 1. So this is negative 1, positive 1, 2, and negative 1. And then I'm going to take that and I'm going to multiply that by matrix 8 and 1. So remember how we multiply? Use our fingers here. Negative 8. Well, first of all, the product of these. Let's set the order. So the order of this first one is a 2 by 2. This is a 2 by 1. Make sure we can multiply them. Yes, we can. The order of our product matrix is a 2 by 1. So that's 2 rows, 1 column. And what's going to happen here is because this side is X, I'm going to solve for X and Y. That's ultimately what I'm going to have. So I'm going to use a different color here. So I'm going to use my fingers here. This is negative 8 and positive 1. negative 8 plus 1, and then I'm going to redo 16 and negative 1. And now the sum of those should be equal to my x and my y. This first one is minus 7. The next one is 15. Voila. This is my answer matrix that makes x negative 7 and y positive 15. It all comes back to this original here, basically setting up our matrices from the example, and the ultimate answer is the inverse of A times B. So to do that, what I would like to show you guys is we are going to use our calculator here. We have not used that in a while, but we're going to use our calculator, and we are going to take the inverse of A and multiply it by B. All right. So first of all, we're going to put the matrices in. I'm going to show you how to do that. Putting in matrices looks like this. There's a button on your calculator that says matrix, so you go second matrix. And here we have an option to put a bunch in here. We're going to let A be the coefficient matrix and B be the constant matrix, just like it is in our example. So A and B, what we're going to do, these are the names of all of them that I have stored in here. Now I want to go over to edit first, and I'm going to hit enter. And first of all, I'm going to set the order of my matrix A. Matrix A should be a 2 by 2. All right, now it allows me to edit my elements. So it's 4, 1, minus 1, minus 2. There we go. There's matrix A. Now just to put other matrices, if I want to put B in there, I just repeat those steps. Second matrix. Go over to edit. This time I'm going to go down to matrix B, hit enter. I'm going to set my order. It should be a 2 by 1. And I'm going to put my constants in there. 5 minus 4. There we go. So this is what I'm doing. I'm going to quit out of this window. And now ultimately what I want to do here, you guys, is I want to take this matrix, find the inverse of it. Let's call that A, because that's my A matrix, inverse of that, and multiply it by this one. I called that one B. So I want to find the inverse of A times B. And I can do that by using my calculator. I go like this. I go second matrix. I'm going to select matrix A by hitting enter. You can see it puts brackets and it's labeled matrix A. I'm going to use this inverse button right here. It's the button right where I usually hit matrix. So it's inverse A times, and now I'm going to go second matrix. I'm going to now select matrix B. That's my constant matrix, and there we go. So I have this situation where my calculator is going to multiply these two matrices, and now it should give me the answer in matrix form for X and Y. And the only thing now you just got to understand is which one's X and which one's Y. Well, since we set it up like this, X is in your first row and Y is in your second row. So the answer to this problem is X equals, let's round here, 0.86, and Y equals 1.6. Now all of this can be done by hand. It also works by hand if you'd like, but just trying to show you guys another option, another shortcut. This last particular problem is a bit of a spicy problem. So in this problem right here, you are not going to want to do this one by hand. This is an example where you have three variables, X, Y, and Z, and I'll just set this one up for you, and I'll let you solve it. But same form, we're going to take the matrix A times X equals B. A is going to be our coefficient matrix, so minus 6, minus 9, minus 1, 3, 2, and 1, 9, 6, and 4. Now matrix X is X, Y, and Z. That's the three variables that represent matrix X, and then matrix B is the constants. 8, minus 2, and minus 5. So in order to solve this system, it'd take us a long time in an algebra 2 world. But in a matrice world, it doesn't. we need to find the inverse of A and multiply it by matrix B. And all of that can be done on our calculator. I'm just going to give you the answer here. I'm going to let you try that if you'd like it. So for those of you guys that did try that on your calculator, here's the answers: is negative 0.6, negative 0.6, and 1 in respective order. So on the test, on our practice, we are just going to practice 2x2s, and they are going to look like this. And you do have choices, you guys. You can either use technology, you can use your calculator to find the inverse and then multiply it by the constant matrix, or you can just do it by hand like we did it in that previous example. Either works. Both will get you that right answer. So that's it for matrices, you guys. Until next time, be clean, wash your hands, disinfect your phones, and most importantly, be kind. Mr. Parker and Mr. Hamilton out.